good stuff. Hey everybody, what am I drinking? I'm drinking Templeton Rye, barrel strength. This is good stuff. Highly recommend it. Anyway, I was doing some reading. I got caught up in something that's probably a little out of my depth, but I wanted to talk about it just a little bit because I find it fascinating. And when I find something fascinating, I feel like I have to share. And today, I want to talk about the periodic table of elements. And I know what you're thinking. Why in the world do we want to talk about that? But just think about it for a second. What the periodic table of elements, what it actually is, it's actually the alphabet of the universe. I mean, really, when you think about it, it's actually the alphabet of the universe. For example, I purchased this. This is the periodic table of elements, and a little piece of every element, except for the radioactive stuff, of course, captured in this. I think this is leucine, I forget, but it actually looks like this, which is probably a little hard to see on camera, which is why I put the blue paper behind it, just so it stands out just a little bit. But I get a big kick out of this. Like I said, I was doing some reading and I just thought I'd share some thoughts on the periodic table of elements, but I'm getting a little ahead of myself. The standard periodic table of elements, at least as we know it, we'll call it the modern period of this table, goes all the way back to 1869, and this Russian cat named Dmitry Mendeleev. Now, Dmitry, he's the guy that came up with this, and he worked for years and years and years categorizing this, which we'll get to in a second. Current day, as of, I think, 2020 or 2016, I forget now, there's 118 elements. 94 naturally occurring, 24 artificial. Now, we'll get to that in just a second, the artificial. The 94 naturally occurring, basically what an element is an atom, right? The entire universe is made up of atoms. And, for example, this is pure silver. So this element on our periodic table would be Ag, which is going to be here somewhere in the middle. Ag, it's pure silver. Its only atom is silver. This is pure copper. So its only element is copper. This is pure titanium. Same concept. The only atoms that exist in these two blocks are the element known as titanium, the element known as copper. Incidentally, these are both 5 ounces. So it gives you an idea of which is more dense or heavy. Obviously, copper is heavier than titanium, both being 5 ounces. I have some others to show you, but that's the basic concept. Obviously, we're made up of atoms, but we're made up of many different atoms. We're not just one single, quote unquote, atom or element. But these 3 metals, silver, titanium, and copper, are all one element. So those are naturally occurring. Those 24 artificial elements, some are known as actinites or actinoids, and those would exist here, down here, I believe in red if memory serves. No, those are in blue, down here the bottom row. And those are basically things like neptunium, plutonium, and most of these came about in the 40s. The last naturally occurring element is element 92, which is uranium. I'll get to that in a second too. And this top row of red, those are called lantanoids or lantanoids. And these are basically the rare earths, the things that we really, really treasure today for our cell phones and for many, many other things. And lantanites or lantanoids, they're kind of hiding in other elements. They're very, very difficult to find, hence rare earths. Cesium would be one, for example. Again, the actinide or the actinoids would be neptunium, plutonium. And a lot of these are radioactive, and are synthesized, so they decay very, very quickly, but elements they are nonetheless. Now in our chart, the lightest element, of course, which is going to be right over here, hydrogen. It's categorized. You can see it's actually separate. This is the lightest element in the known universe at the moment. And the heaviest, as I mentioned, was number 92, which is going to be down here. Uranium, that is the heaviest element. They're broken up into other categories, which we'll get to too. The oldest known element is phosphorus. We've talked about that before. This cat in 1669, Mr. Brand, the devil's element, discovered phosphorus accidentally by boiling his pee and discovered that it glowed. And the newest elements, 2016 is when they were last updated. Prior to that, I think it was 1984, it was Cesium. But in 2016, we added elements 113, 115, 117, and 118, which are right along here, this last little row. Now on my chart, they are not, they're not really given any new names, but today they're known as 113 is nihonium, 115 is moscovium, 117 is tennessine, and 118 is oganesson. I don't really know what they do. Again, these are synthesized. I think they have a half-life of like a half a second, so they don't last very, very long. But everything is arranged by atomic number, which you'll see right here. The atomic number for hydrogen is 1. Then you've got atomic symbol, which would be the letter H, and then the atomic weight. Now again, there's some controversy on weight, because anything above 92, which is uranium, there's no natural abundance, so it's very difficult to categorize stuff by weight. But you can kind of see that helium is number 1, and it's separated from the group. And then you have hydrogen over here, which is number 2, the second lightest. And again, as I said, uranium, which is 92, which is down here somewhere, 92. Uranium is the heaviest. Now they're broken up in groups. There are 18 groups going across, right? You can kind of see 18 going across. And up and down, those are, they're called periods. And it's because they're similar in design. You've got the green guys over here. Those are called alkali metals. These are those metals that if you put them in water, they actually explode. You've got yellow here. Those are called alkaline earth metals. You've got red, which are the lantanoids or lantanites. All of these here. And again, these are all basically came about in the 40s through, nuclear energy, some discoveries. You've got, after the red, you've got purple, which is here in the middle. This is where you'll find gold, silver, a lot of metals, obviously. And the atomic symbol for gold is actually AU. And the reason I know that is because of the TV show Facts of Life, where I forget who it was, but they said, how do you memorize that? Hey, you've got a gold watch, and you say, AU, someone stole my gold watch. For some reason, I remember that. I'm weird. Purple, again, is transition. Then you go to the light blue, which is right here. That's called post-transition. The darker blue is the actinites or actinoids, again, synthetic. Your dark green right here, this diagonal, very, very important. Those are called the metalloids. When you get into this pink area here, those are called the non-metals. Brown are the halogens. And this P, those are the noble gases. Now the noble gases will include things like neon, argon, radium, xenon, all those gases that make light dance. Here in the purple, basically everything heading this way, these are all metals. True metals: palladium, rhodium, iron, cobalt, nickel, copper. Which brings me to well, I showed you these. This is actually bromine. This is actually used in pesticides and things. You can kind of see it's red in color. It's very, very dangerous. If that's exposed to air, it evaporates very, very quickly in kind of a red, smoky or fog. It dissipates very, very quickly. This is actually depleted uranium. I don't know why I have that, but I do. And this is my favorite element. This is cesium. This is how we measure time. Cesium is what all the atomic clocks use. We've talked about this in previous videos. It's so accurate. Every 100 million years, you have to adjust by a second. This sort of proves that time, if you believe in time, because this oscillates or vibrates throughout the universe at exactly the same pace and time. So it sort of proves that time as we know it sort of exists simply because throughout the universe, it does the same thing. And that's amazing. I don't know. I'm just entirely fascinated by this. I wish I knew more. I'm going to do some more reading on it. But you've got metals, then you've got non-metals, gases. There's just so much to learn. And I know very, very little about it. But I truly believe this is the alphabet of the universe, and all of us should be studying this. It's not that complicated. Well, it might be very complicated. I should probably not drink and read. But isn't it amazing? Isn't this amazing? The more you understand about this, the more you'll understand about the universe, just like the alphabet. Once you know the alphabet and you learn to read, there's nothing you can't do. So, if this is the alphabet of the universe, although I looked, there's no J. So apparently chemists and physicists have something against the letter J, and I don't know why. Every other alphabet, every other letter exists except for J on this table of elements. I'm not sure where I'm going with all of this, but like I said, I was reading. I need to do some more reading, but I just felt like sharing at the moment, so I came on and shared. Again, just to recap, periodic table of elements, the alphabet of the universe. And then all of my cilia, I got bromine. Again, I don't know why I have depleted uranium. I'm not even sure how much of this you can legally own, but I have some. Titanium, cesium. Now this is at room temperature, so it's actually in sort of a solid form. If we were to heat this up just a little bit, it would liquefy and be very similar to bronze or iodine or mercury. So many other metals. And the properties of this, it's just fascinating, absolutely fascinating. I just need to spend more time to learn. I don't know. Silver, copper. I've been drinking most of the day, so like I said, I need to stop drinking and reading. So, if you're interested in the periodic table of elements or the periodic table, there's a ton of videos, a ton of information. I highly, highly, highly recommend. I think you will find it fascinating because I do, and I know nothing about it, but I'm going to learn more. We'll probably do another video just because this is so super interesting to me. As you can see, over the years, I've cobbled together crap because who has depleted uranium? Who has a block of bromine? Who has cesium? Well, I think everybody should have this because this is amazing. A 5 ounce of titanium. How much did this cost? I didn't remember buying this. Copper's not expensive. Silver, actually silver, shit, this is probably worth some money. As you can see, it's tarnished and stuff. I don't know how many ounces this is, but there's a serial number on it. See the serial number? Anyway, I've babbled on enough. Periodic table of elements. Check it out. Learn something. Do some investigation. I'm going to do some more. I'll have another video at some point. Thank you, Dimitri. I think this is amazing. Anyway, in this world, when you could be anything you want, you'd be kind, you'd be humble, you'd be forgiving, and you'd be melting snow. And you know what? Do some reading. Read. Take a chemistry class. Maybe I need to go back to community college, take chemistry. I don't know. Did I have it in school? I don't remember. Anyway, we'll talk to you later. Bye.